Good morning. So I'm Phil. Jacob's over there. He's going to come on stage in a few minutes. Welcome to DartConf Day 2. Congrats. This has been a real pleasure so far, and it's a real honor to be up here to show you some new work that we've been doing. So Jacob and I are going to introduce you to the Flutter Widget Inspector, a new tool for the IntelliJ plugin that helps you visualize, explore, and debug Flutter UIs. And if you were at Tim's talk yesterday, you may have remembered him describing Dart as being the engine, Flutter as the fuel. You can imagine a bit that what we're going to show you today is like a diagnostic tool that will help you understand the check engine light in the unfortunate event that it turns on for your Flutter UI. So as it turns out, understanding the check engine light in a Flutter UI is a little bit different than for other UI frameworks. We're going to start by talking a little bit about that. Then we're going to give you some of the basics of the inspector, how it works. We'll do a demo, which I hope you'll find is awesome and will inspire you to give it a whirl yourselves. We'll wrap up with some status and next steps. So what makes an inspector for Flutter different? So the first thing that I want to draw your attention to has to do with the Flutter framework itself. And if you look at this now probably familiar picture of the Flutter stack, the salient bit here is how much is happening up above the engine level. So what you'll notice, it's not so interesting that it's layered as much as how much is up in those upper layers. And you'll think from the tooling perspective, the bit at the bottom, the engine part, is fairly opaque to tooling. What that means is it makes our job a little bit harder because it means that we don't get to leverage a bunch of kind of native low-level tools. But it gives us the distinct advantage of being able to give you a tool that can describe quite a lot of what's going on in a uniform and consistent way. So the next bit that I think bears attention has to do with a fundamental design decision that the Flutter folks made. And the salient thing here, the fundamental bit about Flutter UIs, is that just about everything that you can imagine has been modeled as a widget. So I'll go through a few examples in case you haven't internalized that. So one example that surprised me was to find out that things like themes are modeled as widgets. Animations are also widgets. Apps show up in the widget tree as well. Layout components, and this turns out to be very powerful, although at times surprising, down to things much more esoteric like gesture detection. So this design makes for some unique opportunities and introduces also some challenges. And in particular, one of the challenges that's really kind of fundamental to understanding Flutter UIs is how deeply nested these trees can become. Moreover, the trees are not only nested, they tend to kind of commingle concerns. So you'll notice at the very top and at the very bottom of this tree snippet, those are the widgets that you as a user have kind of invested interest in by defining them in your build method, but everything else is kind of coming along for the ride from the framework. So that's kind of quite a lot to manage. So what that suggests is for a tool to help you successfully navigate a UI in Flutter, it's going to have to be pretty good at moving you between different neighborhoods of widgets and also help you distinguish where your stuff ends and the framework begins and hopefully get you to move seamlessly back and forth between them. So another challenge, although I mean actually I'd say just as much an opportunity, is that widgets in Flutter are defined in source, in Dart source, and not in some kind of simpler markup language. So that presents some implementation challenges for us because it means that our tooling needs to be very robust with respect to understanding Dart source. Now, the good news is we get to build, and we have built, on a rich, open-ended, extensible framework, which you've learned quite a lot about, I suspect, here already. The analysis tooling for Dart is great. So that brings us to what we made. It's the Flutter Inspector is a tool for visualizing Flutter widget trees. And the basic idea is that it helps manage a bidirectional mapping between an active Flutter UI and a visualization of the widget tree that corresponds with it, and also, notably, also the render tree, which we'll talk about in great detail. So further than that, you can follow this mapping deeper into the source so that you can see where in your code or in the framework code these widgets are being created and configured. And it turns out that's very powerful and gives you a lot of clues when you're trying to understand a big UI or debug your own. So that's a lot of talking without a lot of demoing. So let's bring Jacob up, and if we could switch over to the demo machine. And Jacob's password.
All right, so now you've seen my password, so we're all set here. So I've got IntelliJ running with the Flutter Gallery app running in an iOS emulator. All of this will work equally well with a real device. This is just a setup that's easier for me to demo here. And you'll notice currently the application's running normally, but now I'll show you the very first thing you always want to do with the inspector, which is to select the widget you're interested in. So I'll toggle the inspect mode. And now, when I interact with the device, instead of interacting with the app, it's showing me what widget's responsible for that position on the screen. So you can go around and see how this app is structured. Let's go ahead and click on a particular widget. Now, as soon as I do that, now you see the tree of widgets over on the right side here.
Great. So for the purposes of nudging this kind of demo along, I'm going to play the role of a newbie. While I have lots of experience writing developer tools for Flutter, I don't, in my day job, get to do a lot of Flutter UI development, so this isn't actually that much of a stretch. We're also going to fold in a few episodes from some of our observations of folks that are new to Flutter, and we're going to tackle kind of a couple of common puzzles. So to start with, Jacob, why don't we drill in and maybe you can make a source modification.
Yeah. So you'll notice a couple of the widgets in this tree are bold, and those are bold not because of what kind of widget they are, but because of where they were created. Those were widgets created directly in the gallery application instead of the framework. And now you'll see if I select one of those bold widgets, immediately my source window jumps to where I've created that widget right in the Flutter Gallery homepage. And so we'll go over the text one, and here you can see there's where the Flutter Gallery text is defined, and I didn't have to go searching for the text in the source code or anything like that. There it is. Great.
So can you maybe update it?
Yeah, it's pretty exciting. It's amazing when this works for the first time.
So while we're here, why don't we update it to something a little more topical?
All right, let's make this something more exciting. DartConf, exclamation point. And now you'll see everything updated. I just did a hot reload. The inspector understands hot reload as well, so our property values changed there as well. And now we've got our longer title.
Right, cool. So I kind of know where this is going. I'm curious, what happens when you toggle the, so there's a nice button at the top that allows us to toggle kind of our emulator mode so we can get a whiff of what this would look like in Android. We're currently looking at this in the iOS simulator.
All right, so let me toggle it. And we've got a little bit of a problem. That's not the most elegant looking UI at this point.
Right, so what's going on is that the text, there's something about the text, right? It's sort of spilling off the screen. So I'm going to guess there's something about the text.
Yeah, so let's go look at the text. And now here, because we're starting to ask text questions about how this is rendering, we'll want to switch over to the render tree. And just like you saw, the widgets and the source code are tightly linked, the render tree and the widget tree are tightly linked. So if I just click on the render tree tab here, now I see the render tree information about exactly the same widget. So here I can see how the text is set up, and if I even go to the children, I can see the font size. Now let me just toggle back and forth to see if that information changed. Okay, it didn't, so the font size is the same on iOS or Android. That's not the issue. And we can go back up the paragraph and notice that here, the size of the widget didn't change either, so that's not the problem. And you kind of can see that we're on the right track. If you look at the parent data property, that did change, but in a way that's not immediately clear to me why. So let's go look up the widget tree to see what might have caused that parent data property to change. If we go up, go to the align property, you'll notice that on one platform, align is bottom center, while if we go to Android, alignment's now bottom left. So you'll see the property value changing right there. So that's kind of suggesting maybe this was an intentional design decision where on iOS it's centered, on Android it's aligned on the left. But it still doesn't explain why it's going off the screen. Maybe that window's the wrong size or something. I don't know yet. So let's keep going up. Now we get to the padding. And now you can see in the padding is 0 pixels on one platform and 72 pixels on the other. So that's where the problem was. The padding widget is pushing the text off the edge on Android.
Right. So from this, it feels like this is like a deliberate design decision. So on the Android side, we're using a kind of a default like left inset, whereas on iOS we're centering. Can you maybe show us where this is being set, and maybe we can come up with a clever way to overlay?
Yeah. And so when I first hit this issue, I actually didn't have any idea myself why this was really happening. I could guess from poking around that it was a platform difference, but I didn't know. But now that we can jump to source locations for where your widgets are created, it's kind of obvious. Let's jump to where this align widget was actually created. Even for the platform widgets, you can still jump to source. And now I'm in the flexible spacebar widget, just the one you saw up here. Here's where within that widget the alignment was set. And now I can just go follow it back through the Dart code, just jumping to definition. Let me get back there. I usually use a slightly smaller font size. It makes it a little bit easier.
You think?
All right. So now here we are. We're still in the flexible spacebar class, and here's exactly where that code is that says it should be centered on iOS, but not centered on Android. And so it's great. I don't have to look at some C++ code and the platform implementation details. It's right here in this Dart code. And if I keep looking, oh, look, this widget has a property that lets me override the default behavior if I want to.
Right. So now I'm going to guess that maybe when we're setting up our flexible spacebar, we can maybe pass this value in. Maybe we can take a look and see.
Yeah, so let's do that. And once again, I'm just going to navigate using the inspector because I don't want to try to remember where all these source files are. If I click on that widget, I see exactly where I created it. And I just need to add an extra property to center the title. And now, iOS and Android, it's centered on both, and we're all set.
Right.
Yeah.
So, I mean, it's worth pointing out in practice it may not be the right solution, but I think it's perfectly good for a demo. So now let's move on. The next thing we're going to look at is an actual kind of layout puzzle that we've presented to users, and has turned out to be kind of tricky to resolve in practice. And our hypothesis is that the inspector is going to help us with it. So here we have a little demo app, and the puzzle is that you'll notice that the address text is really just spanning half the card, and what we'd like is for it to extend to the entire width. So the puzzle is to figure out how to do that. And it turns out, as we found, it's harder than you might think.
Yeah, a lot of people actually take a lot of time to solve this for the first time. Let's go ahead and select this widget with the inspector just to get to the right code where it's defined. You can see this UI is pretty simple. It's a card with a column and text inside it. And over in the tree here's the column, and it's got text inside it. Now let's understand why this column's the size it is. Once again, we'll go over to the render tree to get information about exactly what the rendered sizes are. And here we'll see, yeah, in the render tree, the width is only 191 pixels, which is less than the 300-something pixels that we're expecting. But if we look at the constraints that were propagated into this render object, the constraints said the widget was allowed to be 360 pixels wide. So that's good news. That means we can probably solve this problem pretty locally. The problem isn't somewhere further up the tree where we constrain the size to be too small. So given that, let's go back to the widget itself and see if any of these properties tell us what's going on. So the first property is the direction. That's actually just because this is a column and not a row. If it was a row, you'd see the direction as horizontal. So then the main axis properties, those are about the vertical axis. So we don't care about those. We're kind of happy with the vertical space. Very next one is cross-axis alignment. Now you'll notice if I mouse over the property, I can see what all the other allowed values are. And looking at this list, stretch looks like what we want because we want to stretch out the column to fit the whole space. So let's go ahead and add that. All right, now the UI updates, and there's the correct column size. Everything's the way we want. You can take a look at it. So we're all done.
Great.
Yeah.
So this is great. So the inspector seems like a tenable way to explore layouts. We're hoping that this makes solving problems like this a lot easier for folks in the future. But what about some of the more advanced Flutter UI bits? Like if we go back to that main landing page, there are a few animations. Can you? Yeah, exactly.
Yeah, so that looks pretty slick, but I have no idea how I do that in my own application. So let's poke around a little bit to see if we can understand what the framework's doing. So once again, I'll go ahead and just select that widget. All right, and now we'll keep going up the tree a little bit further. Notice there's a transform that's applying to the widget, and I kind of suspect a transform's probably what's changing the size. But if I look at the widget tree, I can't tell. So let me switch back over to the render tree. And now I can see information of exactly how that transform is currently configured. Right now, it's scaling the text by 1.5 times. And to see how this animation is going along, and see as I change the animation, that scale, the transform matrix is changing. So now I know exactly how this effect's being achieved. It's being achieved with a transform. And there's how the transform's changing as I manipulate the app.
Right. Great. And then it's worth pointing out that you can navigate to the source, and then we can find the snippet where this was created, and we can just use that ourselves.
Right. So even though this transform is being defined in a library in the framework, we can jump to the definition, and now we can see exactly where they're passing in a scale transform. If we just jump to the definition right there, there's where it's creating a matrix with the scale value, which is tweening between 1.5 and 1 based on this value here. So now I kind of have a feel for exactly how the system is doing it. And this is just inside it's a build method, so I could feel pretty confident I could make the same sort of effect work in my build method.
Right. Cool. So that's a pretty simple transform, but I know there are some more complicated animations going on. Maybe we can take a look at a few of those.
Yeah, let's take a look at a couple more. There's a fun animation demo here that has some more advanced transformations happening. So let's go see if this inspector will also help for those. Go ahead and select a widget, and once again, I suspect there's some transform going on here, so just expand the tree a little bit. I got to the transform, go over to the render tree. Now I'll switch modes again so I can manipulate the app. Now you can see the transform matrix changing as the animation occurs. And of course, I mean, unless you're a lot better than I am at matrix math, you probably don't really know what that's doing from that code there, but let's look at the other property that's being animated here. The opacity is actually changing as this animation occurs. And now this is something that I could actually imagine I'd find useful tweaking this UI effect. So you want to see how faded the widget gets right when it's about to go off the edge of the screen. So now I can see that it's faded to about 0.6 at that point. So that might be helpful for me. But so let's look at another case where the widget inspectors won't currently show you what's going on in the animation, but at least it'll tell you what's not happening in the animation so you can know what to do. In this Pesto app, there's a slick transition between pages here where it looks like this image is just moving up to the top of the screen. So we can find out if that's really happening by using the inspector. Let me go ahead and select the image. And now I'll go ahead and trigger the animation. And the selection disappeared. But as we saw before, the inspection's pretty good at sticking to the render object if the render object's just animating. So this means something more complicated is going on. And you could go find out what that is by jumping to the definition of the hero class that's responsible for performing this animation. And the excellent documentation will tell you how this hero class is actually making it look like it's moving the image, but is really creating a new image at the location of the previous image, and then moving that image over to the location it needs to be for the final page, so that that final image you see is part of the final page instead of part of the previous page.
Right. So, great. So I think that ends kind of the demo part here. And I hope to sum up, we've done a few things. I mean, so one thing is that I hope you've seen that the inspector lets you kind of navigate these neighborhoods of interest in the widget tree. We showed you that great big scary nested tree, but you're not really confronted by that because this bidirectional mapping is kind of ensuring that you're focused kind of only in the area that you're interested in. We've shown that you can do a little bit of spelunking and hopefully solve some layout-related issues. But you can also learn quite a bit more about some of the more advanced features in Flutter, like animations. Can you bring us back to the main slides? So it's worth emphasizing that most of what Jacob showed you is available for download today, with one caveat.
Yeah, that mapping between your source code and the widget tree, that requires kernel transformers that are only available with the new common front end in Dart tool 2. So you'll have to wait till Flutter runs with Dart 2 to use those. You can try it with the flag today, but it's not ready for general use.
Right. And we also on deck have quite a few features that we'll be rolling out pretty soon here, right?
Yeah, this is kind of just the minimum we think will be useful. We're going to be working hard now on letting you tweak some widget properties right inside the inspector instead of going to your source code. I'll let you filter the tree by category. So if you're only interested in layout, you can filter it so you only see widgets that are actually affecting your layout. It's going to make the trees a little bit smaller for those cases. And then we also want to visualize some layout-related properties like padding. You can think of the box model you're probably familiar with on the web. We wanted to show that visually instead of as a string of text. And then coming soon, we'll provide support in other IDEs as well. This currently works in IntelliJ and Android Studio.
Great. So if you want to learn more, we have the GitHub project page is up there. We have an issue tracker. Please feel free to give us feedback there. Flutter.io is a great place to learn more about Flutter. And the Flutter developer community is really great and really engaged. So be sure to go to Gitter or Stack Overflow if you want to engage with them. And by all means, come talk to us. We'll be around for the next couple days. I don't know if we're going to do an unconference or not, but we'll be around in the courtyard and happy to talk about the inspector and all things Flutter and Dart.
Yeah, so come to our unconference session. Well, you can play with this demo and see how it works for you.
Right. Thanks a lot.
Thank you.